Chromatography is the ability to separate chemicals in a mixture using quite often a medium like paper and a liquid like water or alcohol. We've got two strips of paper here, and Joyce, I'll give you one pen and I'll take the other. Let's go ahead and make dots about a ½ inch from the bottom of the paper, and then I'll let you go ahead and prepare the materials.
So what we're doing is we're taking the strips of coffee filter paper and a spring-loaded clamp and then a stick, and we are suspending it in the beaker. We'll do that with the second one also. And then what we do is we add just a little bit of distilled water to the beaker, just enough distilled water so the filter paper is touching the water, but the ink spot is not below the surface of the water.
Why is that? Why don't we want the ink spot below the surface of the water?
Well, if the ink spot was below the surface of the water, the dyes that are soluble in the water would just dissolve out and we wouldn't be able to separate them. What we want to have happen is as the water flows up the filter paper, we want it to carry the dyes along and separate on the paper.
One of the things that we can notice here is the way the water gets carried up the paper. That's done by capillary action. The water flows in between the little openings in the wood fiber and the paper, and you'd be able to see that if you took the paper and tore it and examined it under a microscope. And what we have here is some competition between the water wanting to carry the ink up and the paper wanting to hold the ink back. So we can see that chemicals will separate this way. Let's take some that we had pre-developed earlier, and we'll go ahead and look at them.
And if you notice on these chromatograms, they're not exactly identical. We started out with two black ink spots, but they were two different pens, so the dyes in the pens were different.
Chemists can use chromatography as a method to separate materials one from the other, and if they have standards, they can even identify which material it happens to be when they see the separation occur.
That's right, Bill. Now, Bill, can you think of some examples of everyday chromatography?
Well, yes, I can think of two. The first is when you have curtains in your home, and either you have some condensate that occurs right at the base of the curtain, or there's some leakage around the window that gets on the bottom of the curtain. You'll see watermarks or water stains as the liquid rises up the curtain, and this will go ahead and carry material along with it as it rises up. And we can also notice somewhat the reverse of that. If you dig a hole carefully into the soil in your yard, you can see where the water, in this case, is flowing down through the soil, and it's carrying the chemicals that are on the surface down below. And when you dig the hole carefully, you can see various bands in there where the materials have separated out by the same chromatographic action.